Then we have to discuss maintenance of acid-base balance by what? The kidney, actually. This is one of the functions of the kidney. Now, we have to discuss this, and there are two ways the kidney helps in maintaining acid-base balance. The number one is by reabsorption and production of bicarbonate ion, this HCO3 minus. Now, number two is by excretion of hydrogen ion, either in the form of dihydrogen phosphate or in the form of ammonium ion. In this video, we are much concerned with this first stage. Later on, we'll now discuss the second stage. I hope it's clear. Very good. Now, you can see that I have diagrams on this board. Now, it is very much essential that I describe what I'm drawing here. Very good. Now, this is a part of the nephron. Now, you should know what the nephron is. The functional unit of the kidney is the nephron. Now, you can see the blood vessels that carry blood to the nephron. That's to the nephron, yes, actually. Now, this network of capillaries, what we call it is the glomerulus. The glomerulus located in the bone mass capsule. Look at the bone mass capsule, this cup-shaped structure. Now, the material that are being filtered will now pass through this tube. We call this the proximal convoluted tube. I hope it's clear. Now, what actually happens here is that blood is being carried to this nephron. That's at the glomerulus, filtration occurs, and the materials that are being filtered, they pass here. I've said that earlier. Now again, those ones that are not filtered, because not everything has to be filtered, exactly. Those ones that are not filtered now through the efferent arteriole now pass back. It is going to the body actually. Is that clear? Now you can see that this thing it keeps going on, it keeps going on. I'm very much concerned about this region. Now what happens is that at the proximal convoluted tube, there is what we call reabsorption occurring. Reabsorption has to occur. Does it make sense? Now we should know that we filter for at least 180 liters of blood per day. And among these as a filter substances, only 1.8 liter is taken as urine. Now you can see that out of what you are filtering, 180 liters, only 1.8 as you are going to release that. I'm telling you that it is 1% that will go as urine, that 99% of those things that you filter will eventually return to your body. Is that clear? Now, it is at this stage that we have this tubular as a reabsorption. It will reabsorb most of them. And if it keeps on going to the loop of Henle and the distal convoluted tube, other process keeps occurring such that they keep reabsorbing and forming new things. I hope it's clear. Now, what happens is that from the proximal convoluted tube, the filtrate, you can see the arrow down, the filtrate enters the cell of the proximal convoluted tube. You see this thing that is there? It is the cell of the proximal convoluted tube. Now, from the cell of the proximal convoluted tube, enters back to the efferent arteriole, that's to the blood vessel. Is that clear? Which eventually takes it to the blood, it keeps circulating. So that's what I just said. Now, a more as a pictorial representation of this thing that I've said is all this. I hope it's clear. Now, what is this? This is the proximal convoluted tube, which is you. Now, what is this? Now, this is the cell of the proximal convoluted tube, which is you. Then, lastly, this is now the blood vessel, the bloodstream, which is this guy. I hope you understand this bigger structure. Very good. Now, we start asking ourselves, we've understood the diagram. Now, how does the kidney help in doing this actually? Now, the body cells produce hydrogen ion. And this hydrogen ion, you should know that this hydrogen ion, this is the main component of acids. Yes. Now, it produces hydrogen ion, making the blood to tend towards acidity. We should know that the normal level of acidity of the blood is 7.4. Anytime the blood, as in the body cells, produce hydrogen ion, keep producing hydrogen ion, there is every possibility that the acidity of the blood will fall, as in it will become acidic. And you know that acidity means that as it means going down, that's this value goes down. Now, if the value goes down to something like 4.5 or 5.5, the blood is becoming acidic, and that's a very bad situation. We shouldn't have such thing. Now, the normal range is the normal point is 7.4. That's the normal thing. Whenever the body cell keep making what? Hydrogen ion, the blood tends to become acidic. And hence, something has to be done in order to bring it back to what it was before. And this is what we are trying to discuss. Is that clear? Now, one of the things that help in doing that is bicarbonate ion. Now, how does that happen? Now, bicarbonate ion is one of the as a material or one of those materials being filtered in the blood. Those things that passes here is bicarbonate ion. One of them is bicarbonate ion. And how does this now happen? Will bicarbonate ion now enter the blood streams through it in order to go to the blood and stop as in raise the value of, because we are now assuming that the pH of the blood is around 4.5 or 5.5. With the bicarbonate ion acting as a base to go and raise this value, no, it doesn't do that. Even I have to tell you something that this membrane, this apical membrane, are you there? That this bicarbonate ion is not able, it cannot diffuse on its own to to go inside this cell. It cannot. Now, what actually happens? This this as a reabsorption or this production, reabsorption and production that happens in the plasma of the tube, it started from here. Now, anytime, are you there? This is what we call, you see this thing, this circular something that I do here. This is what we call sodium potassium ATPase form. Sodium potassium ATPase form. Anytime, what I'm trying to say, anytime that sodium, are you there? Anytime that sodium ion leaves the cell and enters the bloodstream, what happens is that potassium ion from the bloodstream enters the cell. Now, what are we trying to say? It's just like give me, I'll give you. Now, if in a situation where that sodium ion leaves the cell, enters the bloodstream, potassium ion will now enter the water, the cell, from the bloodstream. So that those are the mechanisms. Now, due to the reason that this place, remember that I said that you've left and you entered here, so there is no more you here. Now, anytime you become deficient of sodium ion, the cell is not deficient of sodium ion. This one that I drew here, you see this one that I drew here is what I call sodium hydrogen, sodium ion hydrogen exchanger. The exchanger. Now, what happens is that you've identified that there is less of sodium ion here. Now, due to sodium ion is one of the things that the kidney filter as well. It will not pass from the proximal convoluted tube. The sodium ion passes from the proximal convoluted tube through the sodium ion hydrogen ion exchanger to the what? To the cell in order to what? Bring it up again. Remember what I said, that if the person, the sodium ion staying here, left, yeah, hence you that is here has to enter in order to maintain everything. And once you leave here, hydrogen ion in the cell has to what? Leave again. Is that clear? It has to leave. Just like give me, I'll give you. So hydrogen ion leaves through the what? Sodium hydrogen exchanger now and enters the lumen. That's the proximal convoluted tube. It is at this point now that the bicarbonate ion that is being filtered reacts with the hydrogen ion from the cell. Now, once this reacts, it will form what? A carbonic acid. Now, this carbonic acid now as in breaks down to what we call water and carbon dioxide. Now, carbon dioxide is now able, it is this carbon dioxide, and you see this process now, breakdown of bicarbonate, of the carbonic acid to water and the carbon dioxide. It is catalyzed by an enzyme we call carbonic anhydrase. It is catalyzed by an enzyme we will baptize with the name carbonic what? Anhydrase. And anytime this is formed, this carbonic acid being lipid soluble can now enter the cell. Now, the reason why this is happening is because you cannot just enter in. You don't have the ability to want to be as in diffuse through this one membrane. Right here, you have to go down through these processes. Is that correct? You have to go down these two processes so that carbon dioxide, when it enters, it can diffuse. Are you there? Now it goes to the cell. Cells have water. Now it reacts with water to form back the carbonic acid. Are you there? And this also reaction is also catalyzed by carbonic anhydrase. Does that make sense? Now the H2CO3 minor, sorry, the H2CO3, which is carbonic acid, being an acid, it can now dissociate into hydrogen ion and bicarbonate ion. Now, have you seen what I've said? That we are looking at reabsorption and production of hydrogen ion. Now, hydrogen ion was reabsorbed in the form of this. It was reabsorbed in this form. Now, have you seen that in the cell? It has now been produced again. Now, watch out what happened. You see this hydrogen, remember that you now dissociate to give us hydrogen ion and bicarbonate ion. The same hydrogen ion that has been formed will now pass again through the what? Sodium hydrogen exchanger. It will pass through here, enter the proximal convoluted tubule again, so that the cycle repeats. It has to repeat the cycle again. Hence, now watch out, this bicarbonate ion, what it does that it leaves again. Now it can now diffuse or it is passed. It is passed to the what? Bloodstream. Now the bicarbonate ion will now enter the what? The blood. Now you start asking me, since I'm saying that bicarbonate ion enters the blood, how is it then as in maintaining the pH of the blood? Now I want you to understand something. I said that there are two processes. You see the first process, the bicarbonate ion that enters the blood is actually acted by what we are as we call a buffer. Now, it is acted by a buffer. It buffers the system. What is a buffer? A buffer is something that resists. It resists a change in pH. It tells the blood if the blood acidity is 4.5, it tells it, my dear, you cannot go beyond this 4.5. At this point, you have to remain at 4.5. So what it maintains it at that level. What this bicarbonate ion does is that it acts as a buffer, it buffers the system. Now, if the process is now maintains it, or that now brings this pH up to what it was before, 7.4, is the second process, which is excretion of hydrogen ion as dihydrogen phosphate or as ammonium ion. I hope you understand what I'm saying. What I have just said now, represented in an equation, is that when I have something like water, when H2O reacts with carbon dioxide, it will give me H2CO3. Are you there? Now, which will now break to give me hydrogen ion and bicarbonate ion. This is what I just said. Now, to understand that all these, there are rivers. Now, my reaction started from here, which is U plus U. U plus U will give me U, which is this. Then U now has to dissociate to give me this. Are you there? Now, this one now diffuse. To start again, you react, look at it, react, and that's it. Is that clear? Very good. So I hope you understand what I just said, that the carbonic anhydrase, an enzyme, helps in breakdown of the carbonic acid to water and carbon dioxide. And where it works again is when the carbon dioxide reacts with water inside itself to form the carbonic acid. Carbonic anhydrase is same. Please, we should know that carbonic anhydrase is not used in this process. I hope it's clear. So with this now, we've ascertained the fact that the kidney to some extent maintains acid-base balance by reabsorption and production of bicarbonate ion, HCO3 minus. But we should note also that bicarbonate ion, are you there, acts as a buffer. It is not increasing the value that has already distorted. Are you there? What it does is that it goes there, tells you, my dear, you are not reducing again. You will not become more acidic anymore. Now, the second process is that when we discuss it, you will now see where it, as what happens, such that the pH of the blood now will now leave from this 4.5, now go to what it was before. I hope you understand. And you should know that this cycle keeps on going. Anytime you form the HCO3 you form hydrogen ion, you should not see that anytime you form the HCO3 because you are forming something acidic and you are forming something basic. So no one is actually as encountering the other. You understand? So this one goes in, recycle the process. This one goes in here. This one you keep forming it, and that's what this actually does is that it acts as a buffer. And on this, I hope you understand reabsorption and production of bicarbonate ion. Have a nice day.